Okay, all right. So what we're gonna do today is this. We are going to start a brand new unit. Okay, unit 9, day 1. So if you're keeping track of the units, then this is your time to write it down. So in unit 9, day 1, what we're doing are something called sequence. Okay, meaning a sequence of numbers, and there are two variety of them, which is arithmetic and geometric. Okay, so today is strictly introduction. So okay, so let's see what that looks like. Okay, all right, here we go. So now, so if you want to write this down, all right, we're doing sequences. By the way, this is why I'm using this background. Get it? Do you guys get it? Sequence. I think this is how you spell sequence. Is that right? Hold on, I gotta double check because then I'm gonna look like an idiot if I spell this wrong. All right, let's see. Sequence. All right, spell sequence. Yeah, that's right. Man, all right. I checked it. All right, Mr. Ing knows how to spell. Okay, all right. So here we go. All right. So, yep, okay. So sequence. Get it? Get it? Sequence. Sequences. Get it? Get it? All right, okay, moving on. All right, so now, what are sequences, right? So, okay, let's start at the absolute basic. By the way, so one of the things that I want to get through to you guys is that what I'm showing you today is like the absolute most simple way to start the concept, but just in case you're thinking, why am I doing this, and subsequently think that you don't have to really pay attention to this because it's so simple, let me show you where we're trying to go first, okay? So once you see that, then what I want you to understand is that what we're doing is actually can get very complicated eventually. Okay, so this is what we're trying to do. All right, so I'm just showing you this. Okay, so we have to go from where we are today to this point and this point, all that sort of stuff. Okay, so don't take what I'm saying today lightly. Okay, because you have to really follow that very basic what foundation that I'm trying to lay, that so that you understand it down the line. Okay, so pay attention here. Okay, now what's a sequence, right? A sequence is just a series of numbers. That's it. So look at this set of numbers, right? So if you look at this set of numbers, you will realize that, like, well, first of all, we have 1, 2, 3, 4, 5, 6. We have 6 numbers in this sequence, right? So, all right, this you don't really need to know, but I think it's good for me to notate it, right? So hold on. So there's 6 numbers, right? Now, I know what some of you are already doing, okay? Some of you are gonna treat this like it's a IQ question, right? You're gonna try to find out what the next number is and what's the pattern. There isn't any, okay? It's completely random, okay? I just put it in order from least to greatest, all right? Because I want to show you the very, very basic notion, all right? So what is it, right? Okay, one is the way we notate a sequence, meaning like how can I tell you with what position a number is without having to just write this 1, 2, 3, 4, 5, 6. Okay, so that's what I want to get through. How do you know that? How do we notate in mathematics without writing it outright, right? Okay, so this is the notation, okay? Right here. All right, so this is our first number. Okay, so this is our letter A, and then the subscript is N, and let's say this is the first number. Now, let me ask all of you this, right? So let's say, right, this is A's of N. So I'm gonna start at 0 only because I chose to, okay? There's no significance to this whatsoever, okay? The where I put it. So now, let me ask you guys this. If A of N is 0, right, what's the next number? Yeah, it's -12, right? Well, actually, this is not in order from least to greatest. Oops, I messed up there, okay? I thought it was 12. I didn't see the negative, okay? So what now? Everyone knows that, right? So if I were to ask you, right, if I walk down the street and I ask a second grader, I was like, look at these 6 numbers. What's the number after 0? Okay, this is like a bird watching, this is like a bird watches heaven, because right now behind me there's like nothing but birds singing, but it's also very distracting. Okay, again, so if I walk down the street, all right, ask a second grader, all right, and I asked the second grader, hey, I gave you these 6 numbers, 0 is our first number, it's not, but if I say 0 is the original number, what's the number after that, right? The kid's gonna say negative 12, right? Now, first of all, if you're a second grader, you should never talk to a stranger, so, there's that. All right, so anyways, now, what I'm trying to say is, if this were a negative 12, right, using our notation here, how can you notate the next number? So using this as a language, right? So if we decide to use this as the official language of ordering numbers, right? And the original number is a's of n. What would be the next number in the sequence be using this same notation? What do you think it would be? Wouldn't be the same thing, right? What do you think the next number would be? Yeah, plus 1. So this is the next number. Right? Got that? Right? So because it's the current number plus 1 more position. So think of this not as the number itself, but the positioning of the number itself in the sequence. Okay? So again, not the number itself, not the value itself, but this notation tells us what's the position of this number in that order. Okay? Now, let me ask you guys this, right? If I were to ask you, hey, what's the number before 0? You would say that this is negative 1, right? So then that begs the question, how do we notate that? How do we notate that this is the number before the original number? Yeah, minus 1, right? So this is like the number before that, number before the original. Okay, so that's what I want to get through to you first. One is this notation. Okay, so this is chapter 1. All right, what's a sequence? Series of numbers, right? How do we notate the sequence? How do we make a note on the position of the number? Right? A and then the subscript of n. The number after that is a and then n plus 1, and the number before the original number is a and then n minus 1. Okay, how am I doing on time? All right. Now, for our purposes, all right, there are 2 types of sequences and patterns. The first one, right, look at this, right? Now, there's actually a pattern now, okay? So it's not a random set like the one we just looked at, right? So here you've got 2, 4, 6, 8, 10. So let me ask you, right, what would the next 3 numbers be? Yeah, 12, 14, 16, right? So what, how does one number become the other in this particular sequence? Yeah, you add 2, right? So on and so forth. Right? So here, there's a name for this particular type of sequence. Okay, so imagine the parent term, right, or the umbrella term is called sequences. And under sequences, there's a subset. So you got your random numbers, and then you got these patterns. Okay, so now notice, right, again, we just said we're going to add 2 to each of the numbers prior. Right, so each number is 2 more than the one before. There's a name for this. It's called arithmetic sequence. All right. All arithmetic means is just like adding. Okay, that's really all that means. So meaning because we're adding to each of these numbers, that is called an arithmetic or arithmetic sequence. So for example, so this is a vocabulary word that you're gonna find useful, all right? So if someone says, if they added something wrong and you're talking to your friend and you say, man, you can't add, instead of saying, hey, you can't add, there's a more sophisticated way of saying the same thing, right? Like you can say, man, you understand nothing about arithmetic, right? You're lacking in arithmetic skills, right? So that's kind of how that goes. Now, look at the second type of pattern, right? What happened here? Between 2 and 4, what happened? Between 4 and 8, what happened? Between 8 and 16, what happened? Between 16 and 32, what happened? Right, it's not add 2 anymore, right? The lights just went off. It's times 2. Right? Everything's doubled, right? And this is not unfamiliar with what we've just done, actually, right? With exponential functions, right? There's something about this, right? Because this is really 2 to the nth power or 2 to the x power, right? Remember that, right? So there's a name for this. Every time you multiply by that same number, right, it's called a geometric sequence. Now, when we get into each of these topics, I will spend more time talking about that, like breaking it down a little bit more. But right now, I think as a general introduction, it's good enough. Okay, so geometric sequence. All right, and that's what we call that. Okay, now a couple more terms, and then I'm gonna show you just a little bit. All right, just a glimpse of the applications of sequences. Okay, okay. So you see this, the 2's, and first for the arithmetic sequence, right? There's a name for that. It's called a common difference. So we apply that to arithmetic sequences. So this is kind of like the increments, okay? Common difference is the increments of one number to another, okay? The second one, for these numbers, the same number that you multiply over and over, right, as the terms progress, right? We call that a growth factor. So it's almost like, no, I can't use this term because I was gonna go with like unit rate, but it's not true because unit rate applies to a straight line, and this is, as I already said, right, this is a geometric sequence, so the line looks more like that. So okay, doesn't matter. Let's just write this down first. All right, so that number that we keep multiplying, all right, this right here, the 2 here, is called a growth factor. And that's applicable to geometric sequences. Okay, I can't think of this word right now. All right, so the base, right? Remember this. All right, growth factor is very much like this. Remember the exponential function, right? And by the way, this is why we have to do exponential function first. Remember this equation, right? Growth factor. This is the growth factor. This number, which is this. By the way, it's not just r, it's this whole term. So that's why we're gonna revert back, take one step back to the more generic equation was this. Remember that, right? Kind of like that. So this is the growth factor here, all right? And this explains why the 2 here is the growth factor, and then everything is being multiplied by 2. Okay, so that's what a geometric sequence is. Now, very quickly, to show you some examples of sequences in real life, and then I'm gonna stop. Yeah, all right. That's an example of a geometric sequence, right? No, actually, it's not. It's a arithmetic sequence. Oops, take it back. All right, all right. That's an arithmetic sequence. Why? This is a multiplication table, right? What's a multiplication table, right? 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, right? These are all added by 2, right? So that's an arithmetic sequence. Loops, all right? By the way, don't be disturbed by this. I know some of you are like practically not even listening right now, just staring at this. I don't know, it's called fractal hand, all right? I found this on Jiffy.com, and that's it, all right? I thought it would be funny to try to scare you guys a little bit. Fractals, it's an example of a sequence. Okay, so a fractal sequence is something like this. Okay, I'm gonna color code this for you. 1, 1, 2. All right, 1, 2, 3. 1, 2, 3, 4. Get it? Okay, so you see the pattern here. So that's an example of a sequence in fractals. If you want to look into this a little further, I would encourage you to do so. Okay, but for time's purpose, probably not for us. Okay, the thing that I actually really want to get to the most is this. I thought this was the most exciting example. All right, maybe I shouldn't use that word, but the most exciting example of sequences, which is this. This is computer programming, and this is called a loop. All right, so if you're interested in computer sciences, this is for you. All right, so I don't know if you guys can understand this, but this is a loop where you tell, how do I say it? You tell the computer program to do a certain thing, but you want to do it over and over until a certain point. So here, for example, right, like, okay, a little quick, because I did very, very little computer programming when I first got out of college. So, so let's say, right, define a variable, time left, right, the number of times, and then while this number is greater than 0, you print something. You print the time left, and then what you do is you actually take 1 off the original loop. So it's 5 minus 1, right? So now it's 4, so time left is now 4. While 4 is bigger than 0, you print the time again, and then now it's 4, and then 4 minus 1 is 3, so now this is a 3, and then that's a 3, and then you print this again, and then now this is a 3, and then this is 3 minus 1, so now that's a 2. You get it? Okay, I know it's very technically oriented, right? But this is practically like, besides, okay, I would say there are 2 main components, at least as far as I understand, which is not much. There are 2 major components to computer programming, okay? One is using loops and like if-then statements, all right? And the second thing is using SQL, which is, I think, called structured query language, which is how you store information in tables and then how you can retrieve it when you need to. So imagine next time you go online and you order something, right? And you want to track your order to see where your stuff from Amazon is. That's SQL, okay? And anytime your computer does something over and over again, it's probably even this. That's probably a loop, okay? So that's what that is, all right? So I'm gonna stop here because I'm going over time already. Okay, so let me stop here. Thanks for watching. I hope this lesson was useful and understandable. All right, and I will talk to you in the next lesson. Okay, all right, bye-bye.
OMG, that was so good.